of the heliosphere where we've now detected that there's no radial component to the solar wind. So it's almost in a dead zone. And we have asked the spacecraft to help us measure that area by doing a maneuver that it hadn't done since 1990, 21 years ago. We are using the low-energy charged particle, and I'm going to show you on the spacecraft where that is. The low-energy charged particle instrument is located here under the instrument boom, and it scans in a plane in this direction, in this plane. And so what we did just this past March is we asked the spacecraft to maneuver, and so we rotated it along its long axis. We maneuvered it this direction, about 70 degrees, so it now scanned in a plane this way. And so that way we're getting, we're sensing in the environment in 3 dimensions. And so what we do with this maneuver is we rotate it 70 degrees, we hold it for 3 to 5 hours on gyros, and then we continue the rotation all the way around till it gets back to its original point and back to celestial lock. So if I can have the next slide. The last time we did this was back in 1990 when Voyager 1, just as it was leaving the solar system, actually Voyager 1 was out of the solar system, but it was done in 1990 where we could take an image of all the planets of our solar system has dots and put them all together in one image. And I think, as most people would agree, this is one of the iconic images from the Voyager spacecraft. It really puts your humanity in perspective of how small you are compared to how large our solar system is. Now, with this new roll maneuver that Voyager is doing, we plan to continue that every 3 months for the next 3 to 5 years until we hopefully reach the edge of the heliosphere and cross out into interstellar space. If I can have the next slide, please. This image shows you some of the spacecraft that have traveled out the most distance from Earth. In the upper left-hand corner, you can see Voyager 1. It's going up and out of the ecliptic plane. And in the lower left-hand corner, you see Voyager 2. It's going down and out of the ecliptic plane. Voyager 2 was actually launched ahead of Voyager 1 by 16 days. It's the older sibling by 16 days. But it's on a slightly slower, it's flying out at a slightly slower speed because it's on a different trajectory. But Voyager 2 has traveled for 12,273 days as of today. And Voyager 1 is the most distant spacecraft we have today. It passed Pioneer 10 in distance back in 1998. If you had an odometer on Voyager 1, it would be measuring currently 22.8 billion miles. Voyager 1 is 17.4 billion miles from the Earth. Voyager 2, again, is a little bit closer. It's 14.2 billion miles from the Earth. And Voyager 1 is, give you some speeds here, is 61,000 over 61,000 kilometers per hour is its speed, and for Voyager 2, it's just slightly over 55,000 kilometers is its speed. And the Voyager spacecraft continue, along with the Pioneer spacecraft, to travel out of our solar system. Next slide, please. So how do we talk to these spacecraft? I got to give a shout out to the Deep Space Network. They're the real workhorses for us. This is an image of the 70-meter antenna in Goldstone, California. These antennas were actually upgraded from 64 meters to 70 meters back in the late 80s for the Neptune encounter. And because our spacecraft are so far away, the signal is very, very faint. So we need the largest antennas in order to track the spacecraft. I'm going to give you another kind of gee-whiz number here. The time it takes for us to send a command from the Earth for it to reach Voyager 1 is slightly over 16 hours. And for Voyager 2, it's slightly over 13 hours. So for us to send a command, we go into the office Monday morning. We send a command to Voyager 1. And Voyager 1 says, yep, I got it. I'm going to send you a command back. We get that command back on Tuesday afternoon, 32 hours later. And to put that in perspective, a typical Mars mission has about a 10-minute one-way command time. So we're a lot farther out than Mars, a lot farther. If we enroll the last graphic I have, what's Voyager going to do in the future? Well, we have enough power on board to continue operating the Voyager spacecraft to 2020 and perhaps even out to 2025. The only fuel we use is really fuel for rotating the spacecraft. And we use a hydrazine fuel there. We use 1.6 grams a day. We have enough hydrazine fuel to last another 60 years. So that's not going to be any kind of a limiting resource for Voyager. But we're hoping to operate the spacecraft out to 2020 and maybe a little bit longer. We want to get across the heliopause, and we want to get out into interstellar space and take the first true measurements of interstellar space with an operating spacecraft. And when we reach that point, we'll be able to say that the Voyagers are truly traveling between stars. And now I'm going to hand it to Marat, and she's going to talk about her science.
Thank you. Before I describe some of the latest discoveries that Voyager gave us, I thought on telling a little bit of my personal journey into the Voyager team, and I hope I inspire another